In this video, we're looking at how to find the area of a rectangle or a square. Before we get to it, I want to focus on a really important concept in maths, and that's about dimensions. What does it mean for an object to be one-dimensional, or two-dimensional, or three-dimensional? So I'm going to spend a few minutes on that first. If you want to skip straight to the bit on how to find the area, just go to the last 2 minutes of the lesson. It's really quick and it's really straightforward. But I do encourage you to stick with me because it's really important to get a good understanding of this if you want to go and do more mathematics later on. I want you to think about a universe with certain rules. And the rules are that you can travel in the direction you're facing, or you can travel straight backwards, but you're not allowed to go sideways. So I'm going to use a high-tech prop. If this represented you, you would be allowed to travel straight forward or straight backwards, but you wouldn't be allowed to walk like a crab, for example. You wouldn't be allowed to go sideways like this. If you did want to go sideways, you would have to change your direction, first of all, like that, and then you could travel in these directions. Right, to this line. You could start anywhere on this line and get to any other point without changing direction. For example, we could go like this, or we could go like this, and one direction is enough for you to get from anywhere to anywhere else on this line. So, because one direction is enough to go from anywhere to anywhere else, we call this a one-dimensional object. Now we've got a rectangle. This is going to turn out to be two-dimensional because one direction is not going to be enough to get from anywhere to anywhere else on this object. For example, if I was starting down here and this was my direction, I would only be allowed to travel along this line or this edge of the rectangle along the bottom. I wouldn't be able to get anywhere above that. Now, if I started off pointing in this direction, I would be allowed to travel anywhere up and down this line, but I wouldn't be able to go anywhere to the right. So one direction is not enough. Even if I was pointing diagonally, if this was the only direction I was allowed to travel in, I would only be able to go along a line like this. It's just one line, it's not the complete surface of this rectangle. But if we were allowed to travel in two directions, as long as they're not parallel, we could get from anywhere to anywhere else in this rectangle. Let's just think about this. If we wanted to get here, starting from, let's say, here, two directions would be enough. We could travel first in this direction and then in this direction. Two directions is enough to go from anywhere to anywhere else. One is not. Now, some of you might be thinking, yes, but we could have gone from there to there just directly. Well, that's true. But if this was the only direction you were allowed, you would be stuck only on that line. You wouldn't be able to get to anywhere else from this starting point. Now, this might ring some bells. Does it remind you a little bit about coordinates? When we're dealing with coordinates, we tend to start from an origin there, and then we use two numbers to describe any point on a grid. We can use an x coordinate to tell you how far across you go, so that would be travelling in this direction, and then a y coordinate to tell you how high up you go, travelling in that direction. So you can go from a starting point to absolutely anywhere you like on a grid using two directions of travel. And because you need two directions, we call this a two-dimensional object. Next, I want to think about why area is important or why it matters. Let's say I've got a rectangle, so here's just a sketch, and this is 4 centimeters by 6 centimeters. And let's compare that with a square that is roughly the same size. It's a square that is 5 centimeters by 5 centimeters. Now, if I asked which is bigger, it wouldn't be enough just to look at the lengths. Sure, this rectangle is taller, 6 is taller than 5, but it's also narrower, 4 is narrower than 5. So how could you decide which is bigger? It's not enough to look at lengths. What we need to do is find the area. A length is just something that tells you the distance between 2 points. For example, here to here is 6 centimeters. Here to here is 5 centimeters. These are lengths, they are one-dimensional. What we're actually interested in is the size covered by these shapes. And for that, we're looking for what we call an area. And it's a very different quantity. Now, what I'm going to do is take a look at the first example from the lesson. Here was the first example from the lesson. We have a square that is 1 centimetre long and 1 centimetre high. Now, the area of this square is defined to be 1 centimetre squared. The power of 2 there, remember, we can call it squared. So the units of area are centimetres squared in this case, or we could use metres squared if we were dealing with larger objects, for example. So this is the definition of a square centimetre. It's the area you get when you have a square that is 1 centimetre long and 1 centimetre tall. Don't get mixed up between these units. Centimetres and centimetres squared are really different. Remember, a centimetre is just a length, right? That is a length. The area is the entire blue bit. So a centimetre squared represents how much two-dimensional space an object takes up. A lot of the time when we're dealing with concepts like area and perimeter, students get mixed up between centimetres and centimetres squared, but it makes no sense. It would be like asking the question, which is longer, a minute or a mile? Well, they are two different units completely that can't be converted into each other. A mile is a length, a minute is a unit of time. Length and area are pretty different too. In the second example, we had this shape. This is a rectangle, and we were told that it was 5 centimetres that way and 2 centimetres high. Now, what is the area of this shape? Well, hopefully you can see that we can fit in 10 of these squares into this rectangle. Each of these is a centimetre long and a centimetre high. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means we've got 10 of these centimetres squared. That's quite a long way of doing it. Is there a better way of finding out that the area is 10 instead of having to count how many squares are in the shape? Of course, you won't always get questions where they've divided it up into little squares like this. Hopefully though, you can see the answer for yourself straight away. We could get to 10 faster by multiplying the 2 and the 5, and that's going to work for any rectangle or square. The general formula then is to find the area of a rectangle or a square, you just do the length times the width. For a square, the length and width are going to be the same thing, but you just multiply them together anyway. Some people like to use the formula area equals base times height. That works as well. All you need to make sure you're doing is that you are multiplying the perpendicular dimensions of the rectangle. So don't accidentally multiply 5 by 5 in this particular case, just because this side is 5 centimetres long and so is this one. Those are not perpendicular, they're not at right angles to each other. We want to be multiplying the 5 by the 2 to get the area of 10. And remember your units as well. If we were dealing with centimetres times centimetres, we end up with units of centimetres squared. If we had a rectangle measured in metres and we were to multiply the length and the width together, we would have an area measured in metres squared. So that's how we find the area of a rectangle or a square.